Okay, so welcome to my series of videos on managerial economics. And in this particular video, I'm going to be teaching on coordination decisions in game theory. So that is part 4 of my series of videos in game theory. Please do well to subscribe, share, comment, like, and let us have your feedback. But much more importantly, do well to subscribe to this channel so that we can bring you more content. Now, understanding this particular video, to understand this particular video, I entreat that you watch part 1, 2, 3 of my series of videos on game theory before you come to this part 4 on game theory. Otherwise, it will be difficult to follow. Now here, you realize that in all the analysis we've done in the earlier 3 videos, realize that the players, they have competing objectives or they have competing interests, because each of the players want to play a strategy that is best for him. Now, this is essentially because in a one-shot simultaneous game, because nobody knows what the other person will play, all right? Everybody will play his best and then they will end at the Nash equilibrium. However, if everybody knew what everybody would play, and given that everybody has seen the normal form, they could have been better off coordinating to choose a strategy that will benefit the two of them better than playing the Nash equilibrium. Okay. So one of the things I want you to know is that coordinations or forming cartels are usually possible if the game is repeated. Because if the game is one shot simultaneous game, everybody will play his best. Because if it is one shot, you don't have chance to make amends. But once it is repeated, you have chance to make amends even if you don't play your best. And this means that firms can only coordinate or form cartels only and only when the game is repeated. Because once the game is repeated, they would have known the outcome in the first play, and in the second play, they would now agree to play something that will benefit the two of them mutually. So note that coordination or forming cartels is usually possible when the game is repeated. Okay, so let's look at this game here. Now, in this particular game, assuming it is not repeated, each firm will play his best. So let's assess and see the dominant strategy for the two firms. Now, for firm Kellogg, all right, this firm, if we hold firm General Mills at none, the best response for firm 1 is to play moderate, because 20 is better than 12 and is better than 15. If we hold General Mills as moderate, the best response for firm 1 is to play high, because 9 is better than 6. So 9 is better than 6 and is better than 1. If we hold General Mills at high, the best response for Kellogg is also to play high again, because 2 is better than 0 is better than -1. So Kellogg does not have a dominant strategy. He doesn't. Now, if we hold Kellogg at none, the best response for General Mills is to play moderate, because 20 is better than 12 and is better than 15. If we hold Kellogg at moderate, General Mills is better off playing high, because 9 is better than 6 and is better than 1. If we hold Kellogg at high, General Mills is better off playing high, because 2 is better than 0 and is better than -1. All right. That means that the two firms, each of them does not have a dominant strategy. Now, what happens if the two firms does not have a dominant strategy? It means that we have to choose their secure strategy using a maximum approach. Because if one of them had a dominant, the other one will find his secure in the other person's dominant. Now, because both of them does not have, or because both of them do not have dominant, we have to use what we call the maximum. The maximum to choose their secure, because here we would have secure, we don't have dominant. or we don't have dominant secure. Now, for player one, if he plays none, okay, if he plays none, so player one, if he plays none, you realize that the worst case scenario, if he plays none, is that he will get -1. That will be his worst if he plays none among this. If he plays moderate, his worst will be 0 because 26 and 0, 0 is the worst. If he plays high, his worst will be 2, okay, because 15, 9, and 2, 2 is the worst. So maximum means that get the best out of the worst. So the best out of the worst is 2, okay, because 2 is better than 0, is better than -1. That is for player one. Now for player two, if he plays none, his worst is -1 because -1 is less than 1 and is less than 12. If he plays moderate, his worst is 0 because 0 is less than 6 and is less than 20. If he plays high, his worst is 2 because 2 is less than 9 is less than 15. Now, using the maximum approach, the best out of the worst is 2, okay? So it means that for player one, his secure is to play high using the maximum. For player two, his secure is also to play high. So the Nash equilibrium occurs at high, high. So the Nash equilibrium occurs at high, high. But just think about it. Looking at this, if each player knows what the other person would have played, then he will say that they will tell each other that let's play none, none, because it would have given us better outcome than to play high, high. Okay, because if we coordinated to play none, none, we'll get 12, 12. But because we are not coordinating, each of us will play his best. That means each of us will play secure, secure. Then we will now get 2, 2. All right. But mind you, you must know that the decision to coordinate to play none, none is only possible when the game is repeated. All right. Okay. Now, if the game is repeated, the players will know the outcome from the first interaction, and thus they can collude to play none, none. So once they play none, none, they'll be better off than playing their Nash, which is high, high. Okay. Now, the key insight is that collusion can work in a game, in a repeated simultaneous game and not a one-shot game. All right. Collusion can work there. Number two, if we are repeating, we can repeat it because it works in a repeated game, we can repeat it in infinite number of times and then a fixed number of times. But for the purpose of this lesson, let's look at a situation where we repeat it for an infinite number of times, okay? Not a fixed number of times. Okay, so let's assume a situation where we are playing the game for infinite number of times. So it means that we are playing the game forever. We are playing the game forever. Now, another thing I would want us to notice that collusion is only sustainable when either players do not have incentive to cheat. So collusion is only sustainable when no player has incentive to cheat. Once a player has incentive to cheat, then that player will cheat and then the collusion will not be sustainable. Now, if a player has incentive to cheat, that player will analyze the cost of the cheating, as in the punishment for the cheating and then the benefit for the from the cheating. So once a player realizes that if he cheats on the collusion, he will benefit more than keeping the collusion, he will cheat. So what is the punishment for cheating? Now, to ensure that no one is cheated, Okay, each firm will employ what we call a trigger strategy if the need arises. Each firm will employ a trigger strategy if the need arises. Okay, a trigger strategy is a strategy that is contingent on the past play of a game in which some particular past action triggers a different action by a player. So here, what they simply mean in simple terms is that if we have agreed to collude at 12:12 or to coordinate at 12:12, okay? If one person decides to cheat, so let's say we've all agreed that we are playing nan, okay, so that you benefit. Now, if one person cheats, the other one who is cheated or who has been cheated, the next time he will not play the nan again. So let's say player 2, General Mills, has cheated by playing moderate instead of the nan that he agreed to play. Now, Kellogg, once he has been cheated, the next time he will not play the nan again, he will play his best. And remember, in this scenario, his best was secure because he didn't have dominance. Okay, so that means that the secure will now become the trigger strategy because a trigger strategy is contingent on the past play in which the particular action of a player has triggered a different action by the player. So because General Mills has cheated by playing moderate instead of playing the nan that we all agreed to play, Kellogg will now play high because going forward, he will not play nan again. He may be cheated again. So he will now play high. He will now play high, which is secure for him. Now, if he plays high, okay, General Mills will not stay at moderate where he cheated. Because if Kellogg plays high and General Mills plays moderate, Kellogg will get 9, General Mills will get 0. So General Mills will now also play high by responding to the trigger strategy by Kellogg. So now they'll end up at high. The insight I want us to take from this is that anytime one player cheats, okay, the next round that they are playing the game, it will restore it back to the Nash. Okay, it will restore back to Nash. If one player cheats, it will restore back to Nash because the one who have been cheated will now play his best. If it is dominant, he will play. If it is secure, he will play it. The other one who cheated also will now get his best response to the one who has been cheated. Okay, and then they will now end up at Nash. All right. Okay. So anytime there's a cheating in the next round, it will restore the coordination, it will change the coordination from where it is and restore it back to the Nash equilibrium. Now, much more important, let's analyze if there is incentive to cheat. Okay. Now we have coordinated to play nan. So we'll get 12. So if I coordinate, because it's an infinitely repeated game, all right? Because it's an infinitely repeated game, if I coordinate, let's say if I'm firm 1 and I coordinate, I'll get 12 now, and I'll get 12 forever. If I coordinate and never cheat. So it means that if I want to find the present value of this, I'll get 12 plus the 12 forever. We will discount it using perpetuity. So you have 12 over the interest rate. Okay. So this is when I coordinate forever. Okay. Now, if I cheat, of course, looking at this diagram, if M1 wants to cheat, or if M1 wants to cheat and move from nan, he'll go to moderate. He will not go to high because he will not cheat and get 15 instead of 20. He would rather go for the 20. He'll go for the kill. All right. So if he's cheating and Fem 2 still stays at none, Fem 1 will move to moderate and get 20. And then Fem 2 will get 1. Okay. Now, once Fem 1 cheats by playing moderate, he will get 20 now But the repercussions is that once he has cheated, it will restore the equilibrium back to the Nash, okay? So he'll get 20 now, and then he'll get 20, and afterwards he'll get 2 forever because it will restore the equilibrium back to the Nash, okay? So once he cheats, he'll get 20 now, then he'll get 2 forever. So discounting the 2 forever, which is perpetuity, perpetuity is payment over the interest rate. So you have 2 over R. So this is when he cheats. Now, when the present value of cheating is greater than present value of coordination, because they are rational, the outcome is that they will cheat. The firm will cheat. Okay, if cheating is better for him than coordinating, he will cheat. But when coordination is better for him than cheating, he will coordinate. All right. Okay. So let's look at this. All right. Now, assuming the interest rate is, let's say, 5%, that means that if the first firm cheats, you get 20 now and get 2 forever. So 2 divided by 0.05, you get an answer. That is if he cheats. If he coordinates, he'll get 12 now and then 12 forever. If you coordinate, you get 12 now and 12 forever. All right. Now, if you punch this on calculator, you realize that the present value of cheating, okay, you realize that the present value of cheating is equal to 60. All right. Then when he coordinates the present value, you get 240. Sorry, that would be 252. Okay. If you punch it, you get 252. So realize that if he cheats, he'll get 60. If he coordinates, he'll get 252. So there is no way he will cheat. He has no incentive to cheat because coordination is better for him than to cheat. All right. Coordination is better for him than to cheat. So what I want us to note is that here, coordinations are only sustainable when no party has incentive to cheat. Okay. Now, if you want to coordinate, there are certain things you must pay attention to. Number one, coordination, apart from incentive to cheat or not, you must also pay attention to ability to monitor the action of your rivals, because if you decide to coordinate and you're unable to monitor each other, one person could cheat, right? Then also, the repercussions for cheating can also determine the extent to which people will cheat or not. Then if the interest rate is low, we must also look at that. Then high probability of future interaction, all right? So when you are colluding, you must pay attention to these factors. Now, the factors that are affecting collusion in pricing games, number of firms. Here, clearly, we see that if the number of firms are more or plenty, monitoring each other becomes difficult. So if the number of firms are high, it is not good to actually coordinate or collude because the monitoring will be difficult. Now, if a firm has huge size, okay, the firm is able to leverage on economies of scale and then incur lesser cost of monitoring. So if a firm have a huge size, the firm can coordinate because the monitoring cost will not be so much for the firm, all right, based on economies of scale. Number three, history of the market. Now, if that market has history of cheating issues, all right, it is better not to coordinate or collude in that market. But if that market, the history of that market shows that the firms in there are always colluding in a better way, then you can now collude. And finally, of course, the punishment mechanisms. high punishment mechanism will force firms to collude and to cheat. Okay. Let's look at this example and then we'll end the discussion on collusion and cheating issues. Suppose firm A repeatedly faced the situation presented in the table above, and the interest rate is 40%. So repeatedly face the situation. That means that we are talking about infinitely repeated games. Now, here the interest rate is 40%. The firms agree to charge a high price each period, provided neither firm has incentive to cheat, right? Has cheated on the agreement in the past. So they are coordinating to play high. Okay, they are coordinating to play this. Now let's first of all examine the Nash equilibrium. If you examine the Nash equilibrium, we must look at the dominant for each. So if you look at this diagram carefully, the dominant strategy for firm A is low. All right. Then the dominant strategy for firm B is also low. So this one could have been the Nash equilibrium. So the Nash equilibrium is low. But then they are coordinating play high. Now let's see if each of them have incentive to cheat or not. Let's see whether they have incentive to cheat or not. Okay. So if they are playing high, a firm will only cheat if he alone moves to low. So let's say firm A cheats. When firm A cheats and moves to low, you get 50 now, all right? You get 50 now. Listen carefully. They are both at high, okay? So if A cheats and moves to low, so it's supposed to be this way. If A cheats and moves to low, while firm B is still at high, firm A will get 50 and firm B will get negative 40. So firm A will get 50 now, but remember, when a firm cheats, it will restore back to the Nash. So he will get 50 now and get 0 forever. So if you discount the 0 using perpetuity, 0 over 0.4, the interest rate. So the present value will be 50. However, if he coordinates, you get 10 now and you get 10 forever. So when you find the present value, you get 35. Now you realize that if he cheats, you get 50 as a present value. If he coordinates, you get 35 as a present value. So in this situation, if A cheats, he will get 50 present value. If he doesn't cheat and he coordinates, you get 35. So here, what will happen is that firm A has the incentive to cheat because the present value from cheating is better than the present value from coordinating. And because the table is a mirror for firm B to have similar situation, that means that firm B will also have incentive to cheat. Now, what will happen is that at equilibrium, if both of them have incentive to cheat, all of them will play high. All right, because all of them will play low because low will be their strategy when they are cheating. And that will still lead them back to their Nash equilibrium, right? So here, there's an equilibrium result where firm charge high price period. No, the equilibrium will restore to where they charge low. All right. Okay. So this will bring me to the end of my series on, this will bring me to the end of this particular series on coordination games. All right. So the final series of game theory, I'll be teaching on sequential move games. All right. So please kindly subscribe, comment, share, and let us have your feedback. Also like as well, but much more importantly, please subscribe to this channel. So in the next video, which will be my final of the series on game theory, I'll be teaching on sequential move games. Sequential move games. All right. So please, we will meet in the next video. Thank you.